Hey everyone. How is people? I'm doing well. I assume silence means doing well. I assume silence means doing well and eager to do even better by starting my weekend. enough with, Zoom and all of that nonsense. Let's do weekend things. I think that's what doing well and silence entail. Okay, let me pull up the lecture. Thanks, JP. Okay, so we're going to get into cold stress. We're just going to introduce it. There isn't that much to talk about with cold stress, not as much to talk about as there is with thermal stress. So we can actually wrap up cold stress on Monday. We'll introduce it today, just talk a little bit about the history and the context and introduce the concept of the illnesses that you endure and the events or situations, circumstances, environments in which you might encounter it, and then and then we'll stop. And on Monday, we'll get into a lot of the physiology of what happens in the presence of cold. What do we do? How do we detect it? How do we respond? And the limited adaptations we have. But we can bang all that out in one day. Cold stress, we're not as good at tolerating the cold as we are at tolerating the heat. You go play basketball on asphalt, and the adaptations are going to be pretty pronounced for a couple of weeks, right? The adaptations are going to be pretty pronounced, and we adapt very effectively. With cold, we don't adapt all that well. Now, this is the last time that I'll put in all of this thermal physiology. We'll talk about sweating a little bit more today, and not sweating, but we'll talk about cramping. And just to echo those points on cramping, and then we'll get into the cold stress just to introduce it. And some of this stuff is going to make an appearance again, not African sweat gland information, but that speedometer where it says, oh, here's where we get cold, and here's what happens when we get cold, and the hypothalamus. I mean, there are things that are going to come back, but this is the last time we'll look at until we start doing the actual review. This is the last time we'll look at these heat slides. And just like in the water, water is a great conductor. Air doesn't conduct all that much. Water, man, water is you get into that, and you're going to rapidly lose or gain your heat. And so if the water is really cold, you are going to adjust your heat very quickly. And I have the chat box open. So just if you have a chatty question, unmute or chat or whatever away. So you remember all the hydration stuff of how that works, of just making sure that your beverage, your rehydration solution is calibrated for your event, for your stress, for your needs, making sure that depending on how many carbohydrates are in there, looking at the osmolality, and this will look at a little bit again today. That 270 to 290 for the small intestine, especially at the more proximal side of the small intestine. That seems to be where we're absorbing most of our waters, and more proximal in the small intestine, and there's an osmolality there, and the osmolality of your beverage is going to affect your absorption and what happens to your peripheral hydration. So if you have a really high osmolality, something sponsor liquid energy, diluted 1 to 4, that's pretty high osmolality. You're likely to experience some peripheral dehydration when you do that. And the coffee stuff, you can pretty much hydrate with anything. And there's just no evidence when you look through the literature and you summarize the literature, you just don't really see evidence of this stuff. So, what we talked about Wednesday was the cramping and this idea of what people think causes cramping. Go back to the Jazz Age, and uh, we have laborers, right? It's a bunch of miners and people who work with their hands in laborious ways in metal and mines and stuff like that. And we're seeing a bunch of people sweating, a bunch of people in the heat, and they continue to exert themselves. And during and following that exertion, they are susceptible to cramps. And so the prevailing assumption for a long time was that, oh, the heat and the loss of sweat, the loss of fluids, the loss of electrolytes, these are the things that are going to induce cramping. It's not the mining itself, the heaving, the exertion, but it is the altered biochemistry from the loss of electrolytes. It is the hydration that is lost. And so that was the prevailing assumption for a really long time. And just, today, just look at all the different events in which people are experiencing cramping. Whatever it is, these are uh, endeavors of exertion. So you're cycling, you're running a marathon or a triathlon, so cycling, swimming, and it's obviously you have to start in the pool. You can't do the marathon or the triathlon rather and finish with the water, start cramping up in the water. That would be bad. So all right, let's start with the swimming, and then we'll go to the biking, because if you cramp and fall off your bike or something, that's worse, crashing a bike. The safest thing is jogging, so we'll end with the running. Now, as you get more and more fatigued, you get farther and farther into an event, the likelihood of cramping gets increased and increased and increased. And again, what people used to say, and what many people still do, is that, well, that's because you've lost even more fluid and more electrolytes during that time. That's why you're more likely to cramp when you get to the run, as opposed to when you're in the water. It's because at this point you've lost so many fluids, so much fluid and so many electrolytes. But at this point, you're really fatigued, is really what's happening. You're well into the event. Now, so this March 16, 2020, I just wanted an example. You Google this and you'll get 50 million examples. Here's one. Here's webmd.com. This is the actual link. And March 16, 2020, and foods that may help with muscle cramps. And somebody with like 1,000. Okay, whenever your terminal degree is, all of you, it's not going to be the master's. I think all of you are going to go on and well, maybe it's the master's and you go on to business and you go on to like accomplish great things and whatever. But if there's a terminal degree that's a PA, DPT, you're an occupational therapist, MD, DO, PhD, EDD, whatever it is, don't put 1,000 letters after your name. Just call yourself your name. That to me is always the saddest thing in the world. I mean, that's like having a monster truck, driving around town. It's like, okay, just calm down. You're trying to cover up something here with all those ridiculous letters. So I'll go to these presentations. The worst one I've ever seen. I'm maybe this will offend people, but Omalu, the concussion guy, I went and watched him speak. It was the saddest thing I've ever seen. He had like 150 letters after his name, and you go look up what these things are, and it's like a 30-minute online course. Why are you doing this? Why are you putting all these letters after your name? So it's usually when people do that, what it often means is I don't know shit in my head, but I want people to know on paper that I appear to be imposing and this titan of the scientific community and whatever. So here's 1,000 letters after my name. So that to me is just like the saddest thing in the world. So with that in mind, foods that may help. This is probably the nicest person in the world, and I am not that person, right? So if you're driving down the highway and like somebody's on the side of the road with a flat tire, I bet this person would pull over and help them change the tire. I'd be like, you know what, my back hurts, and I'd keep driving. So I'm not saying this has anything to do with ethics. I'm just saying it's annoying when people put a ton of letters after the name because it's just sad. So bananas, a time-tested treatment. You probably know that bananas are a good source of potassium, but they'll also give you magnesium and calcium. That's 3 out of 4 nutrients you need to ease muscle cramps. right? No wonder bananas are a popular quick choice for cramp relief. Okay, melons are the total package. Again, 2020, right? This isn't like 100 years ago. This is last year. This is like right when we went into quarantine is when that happened. These fruits have it all: loads of potassium, a good amount of magnesium and calcium. Obviously, we're just talking about electrolytes here, a little sodium, and a lot of water. Sodium and water are key because as you exercise, your body flushes sodium out with your sweat. Now, remember that your sweat is hypotonic compared to your blood. You actually flush out less sodium than you do fluid. It can be salty, but it's not as salty as what you leave behind. If you lose too much water, you'll get dehydrated, and muscle cramps may happen. Eating a cup of cube cantaloupe can help. After workout can help. And so we're sticking with the premise. This is the advice people still give is not scientific. It is old wives and husbands tales, right? It's these old kind of grandparents tales of what it is. So this is one more in this same article. Tap into tomatoes, juice and all. Tomatoes are high in potassium and water content. So if you gulp down 1 cup of tomato juice, you'll get about 15% of your daily value of potassium. You'll also give your body hydration to prevent muscle cramps from starting. So this is preventive, or what many people would say preventative, which isn't a word. This is preventive for cramps, is what is being reported here. But remember, the small intestine, 270 to 290 osmolality. Let's use science. Let's use actual, evidence. So we're saying drink tomato juice over here, and you'll just stop cramps from even starting. But over here, we know the osmolality of the small intestine. Well, let's pull up an article that does the osmolality of tomato juice. Right. So there's V8 and there's tomato juice. What's the osmolality? It's like 600. And so if the osmolality of your intestine is, let's say, 300, you're doubling that. You're doubling that. You're going to dehydrate yourself with this. And so the advice that you see in this case on WebMD, but usually you'll hear it from anywhere from like Men's Health or the a coach, strength coach, something like this. A lot of the advice that people are giving is the opposite of the truth. It's more harmful than it is helpful. Now, I'm not saying electrolyte solutions are disadvantageous or tomato juice should be avoided by all athletes. What I'm saying is we need to consider contexts. We need to consider environments. We need to consider the athlete. We need to consider the temperature the athlete is exercising or performing in. There's a lot to consider here. Blanket advice, we're so far past the age in which blanket advice is of any value to competitive athletes. Now, Little League, you can say, eat your fruits and vegetables. And you can say that to like Little League athletes, and that's fine. That's wonderful. Like, make sure you stay hydrated. Little League, wonderful, wonderful advice. If you're a collegiate athlete and that's your advice, you're not winning, right? That's not a win streak that you are coaching your folks into. Now, remember with cramping that there's a bunch of different kinds of cramps. And what we're talking about, we're not talking about pregnancy, right? We're not talking about when you wake up in the middle of the night and your gastroc is giving you some grief, right? We're not talking about that. We're talking about exercise associated or exertional muscle cramps. And the early observations that we had were of those like sweaty activities in coal mines and stuff. And so, and you look at the Talbot article from 1935, we're coming up with heat cramps because you're out in the hot weather, the climate is punishing, it's unforgiving, you're sweating, you're losing electrolytes and water, and that's the cause of your cramps. That's what's been said for an awfully long time. But this theory, it's not really sound, right? Because you can test this. In part, you can just have athletes exercise in the cold and they still get cramps. Exercise in cold weather does not inoculate you against cramps. Are you sweating a bunch? No. Are you losing all those electrolytes? No. The fluid is intact. And is the heat doing anything? No. Now, there's a lower risk of cramping in mild temperatures and cold temperatures than there is in hot temperatures, but you're not immunized by having the AC on. Uh, it is a component of a larger picture. There is a lot of inputs to cramping, and if it is hot, if it's really hot out, the likelihood of cramping is higher, but that's not the cause, right? That's one factor in a multifactorial explanation. And if you just induce heat, you're not really inducing cramps. If you apply cooling, you're not relieving those cramps. So you just do you go to the steam room or sit in the hot tub or get in the sauna or go lie out in the sun in Kuwait, and do you lie there and cramp? No, I don't care how dehydrated you are and like, oh, I haven't had, I'm on a water fast for the last, 24 hours and I'm tanning in Kuwait. Okay, well, you're not going to be cramping, right? Because you're not exerting. This isn't exertional environments that would induce this. So you can't just induce heats by getting hot, induce cramps by getting hot. And again, we see this. This is a passage from this article. This is a screenshot from this article, but they're citing again that Talbot, that 1935 article. It's a famous one for a lot of for the literature to cite the narrative, the history. How do we know what we currently know? Where does the start of our understanding of cramps and saline? Let's ignore all this like mouth stuff of like dumping the river into the cave and like this like open mouth gulping. Let's bypass all that. Let's just like you can drink it too, whatever. You drink your salt water, but throw in an IV, do whatever. To increase the amount of fluid you have on board. And people have been, I mean, since turn of the 20th century, late 19th century, people have been using this as both prevention and treatment. Pickle juice is one thing people say, and there is some evidence about pickle juice. Drink your pickle juice. You will find studies. You can look up studies that say, well, the cramping didn't last as long with pickle juice as compared to drinking water. But there's no those electrolytes the cramping has stopped before like the first electrolyte has arrived anywhere of value. And so there appears to be a nervous system response, glossopharyngeal nerve, something like that. A number of explanations for the pickle juice phenomenon have been noted. But 19th century, turn of the 20th century, people are talking about hydration. But we looked at these studies earlier. This 1986 study, they're measuring fluid by blood volume and looking at electrolytes, sodium, potassium, calcium, phosphate. Marathon runners who cramp and don't cramp, and there's no difference, right? Oh, you cramped, let's see what you got. You didn't cramp, let's see what you got. And they're the same, right? We're not detecting differences here. And fast forward the world a decade, and let's look at ultra marathon runners who cramp and don't cramp, and look at the same stuff. Right, just look at all the same stuff that they're electrolytes and blood volume, and there's no difference between those who are cramping and those who aren't cramping. Now, once in a while, you'll see some of the studies, not all of them, but some of the studies will say maybe the sweat has a little bit more sodium. So in this top one over here, this is from the bottom article over here, and a couple of huge authors in terms of muscle cramps on this one. That's what that's from. But in this one, what they found was that, well, there's no potassium. There's nothing going on with potassium. But in the sweat, if you look at if you collect the sweat of people who are cramping and people who don't, maybe there's a little more sodium, right? There might be a little bit more sodium. I think it was like a P of 0.06, something like that. There could potentially be a little bit more sodium in the sweat. Now, what does that mean? Well, we know people who are in better shape, who are better conditioned, retain sodium better, right? Their sweat has less sodium in it. So this could be an indication of training. The people who are less conditioned are likely to have more sodium in their sweat, and the people who are less conditioned are more likely to cramp. Okay, maybe that's the explanation, or maybe it's sampling error because they don't always find this. But it's worth noting that in some work, similar over here, where you see this is in the table 3, the pre-race, immediately post-race, 60 minutes post-race. The sodium is a little bit different between the people who cramp and the control group during the immediate post-race, where the cramping people do have a little bit lower sodium. Okay, maybe there's something small going on with sodium. This level of difference is sort of negligible and unlikely to explain much, but as you know, multifactorial here. So this is from the exact same paper. It says the two main findings of this study were, first, that there is no relation between any clinically significant changes in serum concentrations of sodium, potassium, total calcium, and magnesium, and exercise-associated muscle cramps. And then also with hydration. There's also no relation between changes in hydration status and the development of cramps. So there could be a very slight difference, sometimes observed, sometimes not observed, difference in sodium. There was an ACSM poster. You can find it. It's from 2007. They looked at NFL players, and it's an MSSE, Medicine, Science, and Sports and Exercise. I don't have it in these slides. Otherwise, I would just turn over to the slide and show you. But it's from 2007. I don't know how to pronounce the guy's name. It's like Bartolozzi or Bartolozzi or something. Bart, Bartolozzi from 2007. So you can look this up. And it was looking at NFL players. There's going to be a lot of sweat in you practicing. You're wearing full uniforms. You wear a bunch of uniforms. You get a bunch of sweat, and they also found no difference in that population. More work has come around and just said, like, you know what, we're just really not seeing anything. Oh, whether it's sodium is a little, so there's the control and there's the cramp. Like, okay, the control group is a little bit higher than the cramp group. In there it is, in sodium, potassium, there's nothing going on. Chloride, a little bit, but again, these are sort of unimportant characteristics in terms of the magnitude of difference of these things. And when you actually read the paper, in conclusion, the results is it's not associated with higher levels of the cramps of dehydration or clinically significant differences, clinically significant in serum electrolytes of any of these things in Ironman triathletes. The last one was on ultra marathon runners. But again, it just continues to produce evidence that fatigue, right? It's the fatigue induced alteration of spinal reflexes. And there are particular muscle groups that are sensitive. And those muscle groups, shortened muscles, and those that cross two joints, you get into your whether in the into your hamstrings, right? In your gastroc, the calf, the gastroc is sort of a classic cramper. The rectus femoris, right? The kicker's muscle in your quads that crosses two joints. These muscles that cross multiple joints, and especially if they're shortened, are more sensitive to cramping. For me, the thing that cramps is abs. If I do a bunch of abdominal work and then I sit at a shortened state, it'll just cramp up. And I just don't work abs that often. And when I do, they're going to cramp. I do abs, I don't know, every couple of weeks, every 3 weeks or something like that. I'll do my abs. And every other time I do abs, it totally cramps up if I'm sitting there at a shortened state. If I stretch my abs, the cramp goes away. Now, why would stretching, or how rather, mechanism, how would stretching relieve cramps if it had anything to do with electrolytes or hydration? When you stretch that muscle, do you resolve some electrolyte imbalance? No, right? What you do is you alter the spinal reflexes. when you're stretching. So again, more evidence of this, and electrolyte beverages and hydration. There's sometimes you can see a little bit of a little bit of a difference between people who are staying well hydrated, and you're consuming, you're staying really hydrated with your Gatorades and oral rehydration solutions with electrolytes, and people who aren't. But both groups are cramping a lot, right? You get out in the heat and both, and exercise, not just in the heat, and the heat isn't going to cause any cramps, but you're out there exercising and both groups are going to cramp a lot. But maybe the group that's staying really hydrated and everything is cramping a little bit less. Okay, that's fine. That doesn't mean the cause. That doesn't mean there's anything culpable in the electrolytes doing it. What it means is fatigue, right? What we're seeing is domains of fatigue are going to induce two things. One of them is an increased excitatory input, right? Muscle spindles from the afferents, right? Afferents are sensory nerves. So increased afferents for excitatory input, muscle spindles, and decreased afferent activity for inhibitory input, Golgi tendon organ. And the interventions to relieve cramping are going to address this, and they're going to work really well. Start cramping. If for me, it's my abs. Just stretch my abs, it goes away in 1 second. For people who are doing the, like calves are cramping, I mean, you can flex the opposite, reciprocal inhibition, whatever. But really, the stretch is the most effective thing that's going to relieve the muscle as you stretch it. And what you're doing there is just altering spinal reflex activity. Now, when you see stuff like inadequate conditioning, hot and humid environments, these are contributing. They're contributing to this phenomenon. This would be the fit characteristics, right? FITT, frequency, intensity, time, type. Maybe not frequency, but the intensity, the time, and the type of exercise are all going to contribute to fatigue, to acute fatigue. And these cramps can persist for 8 hours after exercise. There's evidence that after the cessation of exercise, when you're done, when you're just sitting around, you're like watching TV or something, the cramps can persist. It's not only while you're exercising, it's following exercise, you're at an elevated risk. But this fatigue and this alteration of spinal reflex. Now, obviously, if there's like muscle damage or something like that, that can play in too. Altered central nervous system function, that can play in too. There's a lot of things that can play in. Go exercise in the heat, and that's going to be worse. Exercise in the heat and get all this fluid loss, everything, that's going to be worse for developing this phenomenon. But it's not causal, right? That's not causal. That's just a characteristic of fatigue. That is a very strong correlation sometimes, depending on the context. But those spinal reflex arcs, that's seems to be where all the compelling evidence is the culprit. So we have this reduction of Golgi tendon organ activity, an increase in muscle spindle activity, and then the muscle decides to cramp. It decides to misbehave. And again, when you look at this passive stretching as a therapy, that's really what you're addressing with passive stretching. And so the population differences, again, people are resident to some areas that are hot. You're in, Pakistan or United Arab Emirates or something, and it's just super hot all the time. And or you live in Seattle, and it doesn't really get, it's sort of cold in the winters. It's not terrible, but it's a little cold in the winters, and never really gets all that hot. And so there are different populations, but even people who are residents of, go to like Uzbekistan. I assume it's hot there. I don't know. I've never been. And just go winter in Maine. You're a resident of Uzbekistan, and you go wintering in Maine, and you're going to lose your heat adaptation, right? And so now from that winter, you're going to go exercise in the heat, and it's not going to be good. You're not going to be good at it. You can lose some of that heat tolerance. And you can see this with, the West African athletes during the rainy season. They're not as equipped. Now, old people, young people, not as good at tolerating the heat. Kids have tiny bodies, and the heat just blows through them, right? So they're going to acquire heat pretty readily. And they're not very good sweaters. Kids and old people, they're not very good sweaters. You all are good sweaters, probably. You probably have a good sweating capacity, a good ability to cool. Kids and old people, they don't really have that. And but kids are going to generate heat metabolically, while old people don't. Old people are usually the most susceptible to the heat waves. But we sweat faster and more total sweat, and it comes on faster. But it's also more diluted, right? That there isn't as much sodium in the sweat of a conditioned person. And so again, when you see crampers and non-crampers, you're like, well, in some of the data, not all of it, but in some of the reports, there's a minor difference in sodium. Is it a difference enough that would actually induce cramping? Well, no. You can just induce that change in sodium in people, and you're unlikely to see a difference in sweating if you induce that change in people. But the people themselves, the type of people who, if you've taken, me in stats, epidemiology, or whatever, I say this sentence like 100 times during the semester. The type of people who are going to lose a tiny bit more, not a practically meaningful amount of sodium, but a detectable amount of sodium more during exercise, are likely to be the type of people who cramp. They're the type of people who are less conditioned. Saying one causes the next is sort of the great statistical fallacy, the error people make in research methods. But this more dilute secretion from the eccrine as opposed to apocrine sweat glands. You're not really cooling with the apocrine. And then the reduced heart rate at a given intensity, and the blood goes where it's supposed to go. A couple of weeks, you just need a nice, 2-week phase of training. You're not going to do it by lying in the tanning bed, or by getting in the sauna, something like that. That's not going to help you condition for training. Specificity of adaptation, you have to actually do the tasks that you want to condition for. So moving into cold stress, that's it for heat stress. We're done with thermal adaptations and thermal load and its consequences, its illnesses. We're done with all that. Cold stress is easier, and parts of it are interesting. When we talk about the hunter's effect, we'll do that on Monday. That's fascinating how stuff like that works, and you can feel it if you've ever been like really cold before. Maybe this is something you've experienced. But coming back to this idea of there's a comfortable space that we have for our body, right? This isn't like a comfortable climate to be in. 98 degrees, 99 degrees, whatever. That's not like the climate that you're comfortable in. But your homeostatic point for your body, nice, comfortable place, and all of this is going to apply for cold stress as well. So Claude Bernard, this is where the thinking about regulation of these things began. He was a big investigator, Claude Bernard, of what the pancreas does and how the liver is going to help regulate sugar. So important work in understanding diabetes. Claude Bernard, 19th century, a lot of this foundational work there. But let's just go back to this idea of where the semester began as we transition into cold stress. A little reminder that we have to maintain homeostasis, a set point, some biological condition. And that's when blood sugar and blood pressure and body water and ion concentrations and gas pressures and pH and ATP storage and temperature, right? So there's a set point for temperature that we have to maintain, but all of this stuff has to be maintained. Now, Claude Bernard is sort of famous for his terrible performance for medical school. That wasn't what he was good at. Michael Jordan was a phenomenal basketball player. And surprisingly, he was okay at baseball for not being a baseball player. Surprisingly, he actually wasn't horrible, but he was a phenomenal basketball player. Then with Claude Bernard, we have something similar where he was a phenomenal sort of in the physiological philosophy domain, where he was this great researcher and thought broadly about these topics in ways that people hadn't considered before. So the milieu interior, the internal, your interior environment, this was his idea of this thing is constantly correcting itself, right? Your internal environment, your internal biology, you're being threatened by gas pressures and temperatures and pH and all, and you have to constantly correct. So it never slumbers, right? These corrections, the vigilance of your body to constantly correct. And again, big sort of, pre-diabetes researcher of how are we regulating, blood sugars. But he was a great researcher who contributed to the understanding of homeostasis. Homeostasis itself, the word, the coinage, that was Walter Bradford Cannon, 1926. Fight or flight was also his, a decade before. Fight or flight, that was his coinage as well. And this is a really cited researcher this is 20th century, but one of the top 100 most cited scientists of the 20th century, this really influential scientist, but homeostasis as a coinage of taking Claude Bernard's idea of this internal environment that's constantly watching out for disruptions and disturbances and threats and correcting itself. Walter Bradford Cannon is the guy who's coined some of this, but again, as a reminder of where this semester began, very narrow window. We're walking that tightrope of survivable conditions. Our temperature barely shifts, our pH barely shifts. And at first we're ill, at second we're dead. And so we constantly have to correct it. And this idea of what stress physiology is those responses, right? This is the Claude Bernard responses of we're just making minor corrections, because if we have to make a major correction, we're probably in the hospital. So we're constantly making minor corrections to stay balanced on that tightrope, because pathophysiology exists right on the perimeter of regular physiology. I lived in Chicago for a while, and the houses there are not in the shape of squares. They're these like really long rectangles, and the entire width of a house. It's like I'm in my laundry room right now. That's about it. The width of the house is like my laundry room, but then it goes back. You can have this house that's like the size of an acre, but it's a hallway. Every house is like a hallway. And the neighbor lies on, like, you can practically hold hands with your neighbors while in the middle of your room, in every room that follows. And that's sort of the environment, right? At the wall, like you have this narrow space and both walls are pathophysiology. And we're sort of just racing through life with all of these threats, and both walls are death of we have departed homeostasis far enough. Death, the temperature, if your core temperature, now this does get pretty low. If you're thinking 98-ish, then you're getting down to 78-ish. You're dropping like 20 degrees Fahrenheit, go from 37 down to, 25, 26, 24, something like that. And that's a pretty low core temperature, but the body shifts pretty quickly. Hypothermia, mild, is like 35 degrees Celsius, 95 degrees Fahrenheit, mild hypothermia. And anything above that, or below rather, anything colder than that, and it starts to get a little bit more severe, a little bit more associated with patho conditions, with deterioration, with threat, and eventually death. Frostbite, frost nip is like one of those, like, who cares? You're just complaining. Frostbite, that's the more permanent one. But mild hypothermia, and we'll go through some of these conditions a little bit more thoroughly on Monday. This is just, I'm introducing the topic. The speaker will be here on Monday, and I am the person introducing that speaker. That's what this is. This is just a, at the end of today, I'll say, without further ado, and a condition that needs no introduction, and I go on to introduce it. But so mild, right? You're going to get this sort of pale color. shivering a little bit. We've all felt shivering and numbness. Your fingers, you have no dexterity in your fingers. Just try to play piano or guitar or video games or type, whatever it is, when you have hypothermia, and you lose that dexterity. We'll talk about that on Monday. You start to really lose motor coordination, and as hypothermia progresses, you can get slurred speech, and the shivering just gets out of control. And in these situations, earlier in the thermal stress slides, when people were biking or people were swimming, and there was a temperature that was really cold that associated with a higher VO2 max, and then as you warm up a little bit and you perform optimally, you get a little bit hotter, a little bit hotter, a little bit harder, and your performance just tanks and tanks and tanks. But the optimal performance wasn't like freezing, because when it's really cold, you're shivering, and all of that muscle activity is consuming oxygen, and it would be better if you could use that oxygen for pedaling or paddling, if you're in the water, for whatever it is, or like puttering along if you're jogging. It would be better if you could use those calories for those functions. So performing in the cold can be a little bit compromising, especially when the shivering starts to get the best of you. When it gets severe, you bradycardia, your heart rate slows down, and you have these um, waves of shivering, and your breathing gets weird, and mobility departs you. It gets really severe, and it can set in with relative haste. Hypothermia can. Wet skin, as we know, that's the if you like fall into the water and you get out, you better get rid of those wet clothes, right? You're just going to have all of this preservation of the cold and the evaporation and the contribution to added frigidity. Um, Poor food intake. There's a thermic effect of food. Every time you eat, you're going to warm up a little bit. And if you are, let's say you've been fasting for 48 hours, 72 hours, something like that, you're going to be transitioning into a state where your metabolic rate begins to slow down a little bit. And 24 hours, 36 hours, something like that, you don't seem to see in the literature. I have not seen a collapse of metabolic rate on these short fasts, these sort of 1 day fasts. But you get into like day 3, day 4, or whatever, and your metabolism starts to get mighty sluggish. Now, remember that thermal load equation. As metabolism speeds up, right? Again, metabolism as the speed is a weird way to characterize it, because it's this sort of summation of chemical reactions. You have anabolism and catabolism, but as your metabolism is more, it's you are more catabolic or more anabolic, and you're doing more of these chemical reactions, there's ATP consumed in metabolism, and that's a major, 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 major component of your thermal load. And if your metabolism sucks because you've been like starving yourself, hey, you're going to freeze. Alcohol intake, we'll talk about that a little bit, because your body's trying to preserve heat. In the cold, your body's trying to preserve heat, so it's sending it to the core. You're sending it into core, meaning organs. Core, not like my abdominal muscles get super bloody. That core is like your heart and your lungs and your spleen and liver and kidneys, and well, that's what I mean by core. And you're trying to send all of your blood, all of your 37 degrees Celsius blood to your core, and make a stark gradient where you have this as much space and right in the core it's really hot, and you have this big gradient where the skin is like the same temperature as outside, but it's going to take a while for the outside temperature to find its way to where you're all 98 point whatever degrees. You drink alcohol and you mess all that up. You feel warm for a minute, but you just totally mess it up. We'll talk more about that. Yeah, obviously improper clothing. I mean, just go like be a nudist in um, Minnesota in the winter or something like that's inappropriate for maybe indecent exposure, but worse for your health, right? So there's a lot of factors are going to contribute to fatigue, but cold exhaustion. Um, obviously we're going to see lower body temperature, but we might get into hypoglycemia, cerebral function. Just like if somebody gets, they're running at the end of the marathon and they're getting hypoglycemia from exertion, from it's hot out, and their blood sugar gets low and they get loopy. So you can get that same thing with cold exhaustion and the corresponding confusion and poor motor coordination. Frostbite, here's what it looks like. We'll talk more about these symptoms, these conditions on Monday. But first degree, second degree, third degree, fourth degree, that's getting bad. Over here, that's okay. We could all use a little bit of first degree frostbite now and again just to remind us that the world is punishing. You don't want to go beyond that though. Now, athletic environments, athletic contexts where you might encounter the cold. This is obviously stuff I wouldn't be asking about on any sort of test. But we know where cold is felt all the time. It's just like all around you when it's not summer outside. In the winter, it's always a little like you turn the heater on and you use blankets and you have a sweatshirt and stuff. Like the cold is everywhere. But some famous sporting venues that take place in the cold. Okay, we know what Iditarod dogs are, where it's like a dog sled and you just go forever. And like the human is riding the sled. The dogs are the one doing all the labor. And those dogs have really impressive VO2 maxes. There are some animals that are impressive distance runners. It's like the pronghorn antelope or whatever. Camels are actually phenomenal too, but Iditarod dogs. Now, if it's like California, is an Iditarod dog going to be able to beat you in a marathon? No, they're going to go like 100 feet and then collapse of a heat stroke. But you put them out here in the tundra, and those Iditarod dogs are amazing endurance athletes, really remarkable. But people in the cold, yes, we're good endurance athletes in general, especially in the heat compared to other animals. Camels are wonderful in the heat, but especially in the heat compared to most, I don't know, fauna of the world. But just have a person run the Iditarod trail, and we do this, right? There's people every year who are going to do this. You can do it on bike. You can do it on foot. The bike isn't all that helpful because you're going through the snow. It's like hard to bike in the snow, but you can do it on bike or foot, and they tabulate times and winners separately. So there's males and females and bike and feet, and it's something like $1,600, something like that, to compete in this thing. There's a 350-mile race, and there's a 1,000-mile race, and the winners and the losers of these things, the winners, I guess. Let's just talk about losers. Everybody's kind of a loser. There's like very few people actually finish. That's the losers don't finish, which is like the bulk of people. Very few are going to finish, and there's a maximum number. You can go to this website. I looked at it this morning. I looked at the website and the 2020 finishers. There's quite a few for 2020. Quite a few finishers, and the times for the finishers. It was something like for the 1,000-mile race, it was like 20 days, give or take a couple of days. For the 350-mile race, it was like 5 to 10 days, give or take. Maybe there's a 4-dayer here and there, a couple of weeks here and there. But the finishers, it takes a while to go through this. You have to carry everything, and most people don't finish. It's just the cold. Go about being the cold forever. Really tough. This one, the Arctic Ultra, 6633 Arctic Ultra, either 120 or 350-mile race in the Arctic Circle. And you have to just drag all your gear with you. That's sort of the premise of these. You don't get a Sherpa. You don't get a drive along car, right? You don't get like some like remote control car that follows you, little robot or something. You just have to carry everything, but you can get temperatures below 25 Fahrenheit, like negative 25, below negative 25 Fahrenheit. And as soon as you put wind chill on this stuff, it gets really, really punishing. I've driven coast to coast a couple of times, and I was in Nebraska, York, Nebraska, and it was winter. And I don't know what the temperature was. I think it was like 2 degrees Fahrenheit, something like that. and the wind was really blowing and it just hurt. I mean, I could only be outside for like a minute, and it was so painful with the wind. When the wind would stop blowing, I could stay outside, you know, briefly, but it's 2 degrees or whatever. It's still really cold. But as soon as that wind starts blowing, that is painful. And so the wind chill with cold stress is a lot like humidity with thermal loads of heat stress. And so we always lump these things together. Heat and humidity is sort of one stressor. Cold and wind chill is the opposite stressor. So those wind speeds that can really exacerbate this stuff. Very few people finish, right? The first one of these was 2009. And so, the 2009, 10, 11, 12, 13, 14, 15, they've done a lot of these annual things, and there have been 11 finishers. It's like nobody finishes. I mean, it's just partly because that just looks boring. I mean, there's like nothing to look at. It's kind of cool at first, like, ooh, look at this glistening snow sort of gilded by the sun's rays. And we're like, oh, I guess there's no sun, and this is like, boring me to death. The North Pole Marathon. This is the last one we'll look at. It's just a marathon. It's an actual, normal marathon, and it was super expensive, right? Those souvenirs better be worth something to you. But a lot of the costs of these things, that Iditarod one, last time I looked it up, it was $1,600. It's probably more now. That was a few years ago. It was the last time I looked up the price. But the cost of a lot of these, just like that jungle marathon or the Badwater marathon or Marathon of the Sands, all these things, really high price tags, in part because there has to be so many safety measures, right? And there's so much liability, and the insurance must be outrageous. But this is a fairly impressive record for something that happens in the North Pole, and to complete the marathon. And what a lot of people can do this, you're like, I'm pretty good at the marathon, I got it in under 4 hours, and that's reasonable. But to do that at the North Pole, there's something to applaud oneself about. Okay, so that's the introduction. That's like before cold stress takes the stage on Monday and we start talking about the physiology of how some of these things work. This is me introducing it and then handing over the mic. But that's it. Short lecture for today. That was fuller than I thought it was. Any questions? Is this us ready for the weekend?
I have a question for you,
Yeah.
but it's just like completely unrelated to class.
Okay. Yeah. Are
Yeah.
there any class questions first before we do the potpourri? All right, Lexi, let's hear it.
Oh, it's about the research competitions. You know what I'm talking about? There's either the poster or the 3 minute.
On campus?
This year it will be online.
Okay. Okay. Yeah. So I'm familiar, but I've never actively participated in that before. Participated from a professorial supervisory role. But I'm familiar with the premise.
Well, basically they have you talk about your research, and you could do it in two different ways: the 3 minute presentation or the poster presentation, because they encompass different qualities when introducing your research. But I guess my question was, I talked to one of the coordinators, and I kind of told him, I was like, look, because they kind of require you to upload abstracts.
Okay.
And I told him, like, look, like, what if we were to upload one, like, but it's either already published in a medical journal, or, there's a possibility it might be. He basically said, like, it will not be uploaded through UOP. But I wanted to give your insight on it because I feel like with all the chaos this year, mistakes are bound to happen. You know what I'm
Mhm.
talking about? So,
Do they upload the non-published or pending publication ones, and they would make an exception for the published ones, or do they just upload none of them?
they would, like from what the coordinator told me, like he would actually reach out to each individual student and confirm whether or not this is like a published or a potential paper that might be published. And
Okay.
basically, like it'll be discussed and talked about for the time being, but then none of the materials or even the abstract itself will be uploaded. It'll just be completely
Okay, I'm fine
um,
with that. Yeah, but
okay.
as long as the students who are participating are both vigilant and proactive, where because we don't want a hassle. What we don't want is like we put in all this work for a publication, now we don't get it, and we have like hours of correspondence with ACSM over our like a breach of duty to keep the, because we're like, I mean, there's policy that we would be breaching, and to avoid all of that, I have a hard time just trusting administrators to understand the research process. Just like I've never been to a single one of these research Tuesdays that's been happening. And like
Mhm.
what department on campus does more research than the rest of campus combined? Ours. Right, put the dental school in with the farm program and everything, and what is the single most prolific department in all of University of the Pacific? It's our department. And like I've never once been to one of these like Research Tuesday events. That's like they can't. I think it was like every week people are going and presenting whatever research and stuff. Like, well, we like publish for real. Um, but I think this stuff is very valuable. That this local campus stuff is very valuable as dress rehearsals. Like people don't. I mean, show up to, I don't know, it's a wedding, it's an event of some sort, and there's always like a dress rehearsal the day before of like, I just want to make sure everything goes right, and I think that's a very valuable experience to have. And I would definitely encourage people to do it if the students who participate are proactive in making sure they don't post something online that is ethically and legally bound to, it's like once ACSM accepts it, we don't even own those words anymore. Like it's copyright infringement or plagiarism for us to actually quote ourselves, because those words don't belong to us. They belong to ACSM, MSSE, and uh, some journals. I can't be 100% positive on that, because some journals leave the rights to the authors, but I don't think MSSE is one of them. So yes, I'm in support of it. I'm in support of it, but just trusting that Pacific admin is going to keep, if you just tell them once, like, oh yeah, hey, I'd rather this not be online, and you end it there. My concern is there's like a coin flips odds that it's going to wind up online, and then from there there's like a coin flips odds that it would be problematic, because maybe it wouldn't be problematic, but I just don't like risking things. I'm I don't know what to like. I'm trying to think of like a G rated. It's easy to come up with like an NC-17 rated thing about risk, but you get the idea. I don't like unnecessary risk, and so just to be very proactive and use your prophylactic emails of saying, just a reminder. So I think I've overdone my explanation.
Oh no, I totally get what you're saying. And like I'm definitely gonna email him multiple times
Good.
reminding him of this, but like I just wanted to get your thought process on it because like I said, I think in the past maybe they're more reliable, but because everything's transitioning and it's a newer platform this year. You know what I mean?
Yeah,
Like
and I do think it's very valuable. I totally know what you mean. I do think it's valuable, and you get a really good dress rehearsal. There's nothing. There's It's not worthless. Now, I think sometimes, I think maybe this next year, some stuff that we've had rejected in the past that we don't get accepted. I think we should do the regional ACSM, because I think it'll be live the next one, and it's probably going to be in San Diego or San Francisco or maybe even like Sacramento, something like that. The Southwest ACSM, because pretty much everything that's reasonable gets accepted there. National ACSM, the rejection rate is higher. Regional ACSM, the rejection rate is really encouraging. I mean, it's like, yeah, maybe something will get rejected now and again, but the quality of our work, it'll be 100% acceptance for that one. I mean, people who just like don't have sponsors and there's like typos and or the science is bad or something like that. But they don't really care about impact of the research. They just care that the research is sound and it's well written and whatever. And so the regional ACSM is another thing that we could do. They don't publish, but it's another thing we could do to for the sort of dress rehearsals, and it's sort of fun in the way the ACSM is fun. There's a community there, but it's all the California community of ACSM, and it's at a smaller hotel with they just take over like the two ballrooms or something. So it's not like national ACSM where there's 10,000 people at the conference, whatever. More, but so I do think the local Pacific one, regional ACSM, I think both of those will be valuable things to start doing, as long as we're cautious about keeping printed or otherwise posted material exclusive to our real venue.
For the regional ones, you said they don't publish. Could you resubmit them to the national ACSM?
Yeah, that's I've done that a couple of times. I presented at the regional ones. It's almost never posters. It's usually you're given somewhere between like 5 and 15 minutes to get up and present, and it's a wonderful experience. It's lower pressure, and often you have a bigger audience when you're presenting, and you'll do a slideshow. So it'll be some PowerPoint slideshow, and it's fun. It's the regional one's really fun. I haven't done one in years, but I did it a couple of times in the New England chapter when I was living in Connecticut. It was super fun. But so what I would do is I would submit to the regional and to national, and then I would present on in PowerPoint my poster, and the exact same abstract would be submitted to the national, and that's totally fine. That's the ACSM is happy with that. That's what most people do, and so that would be the warm up would be the regional going into the national.
That's a great idea. Like, I'll start getting a group together now and kind of planning that, assuming
Okay.
they're still going to be in person. But yeah, it's a great idea.
Yeah, and so all of these unpublished things are totally reasonable, respectable, valuable pursuits. What goes on your sort of permanent, resume CV is the national ones. And you can have some little section somewhere of like, unpublished conference presentations, something like that. But the national ones that publish, experimental biology, um, there's the American nephrology one that we could do if anybody wants to do kidney stuff. I did that with Alexis once. But there's I think two Alexises here, but our original, our first Alexis, um, Alexis King. But so there's stuff that there are other conferences, national conferences that publish in good journals that we could do as well. But anybody who's interested in doing research, I mean, you really are in the right department to do it. And I'm happy to help in any way. Just if you're motivated, I don't know. Let me know. I mean, obviously, like the Nathaniels and Lexis and people who've at Genevieve and the people who've been doing research and Cameron, I'm looking at you, I see you there, and people who've been doing research for a while know exactly what you're doing. But people who haven't yet, dipped your toes in that water, it's enjoyable and it's not that much work.
Not that much work.
Okay, it's quite a bit.
My ass off.
Yeah, no, that's true. That's true. But it's not. There's an assumption that research is like, well, it takes like 2 years to do this thing, and like not if you just have data. If you're sitting on data, like my first lab that I was in at UConn, I was there for 3.5 years. I did 3.5 years of data collection, and then I was gearing up to. I did one national ACSM abstract on it, something about like HIV and health outcomes, something. But I did two abstracts, but I was 3.5 years of data collection. 3.5 years, and then I did like one, maybe two abstracts off of it, and then I stopped. But now, I sit on piles of data, And you can mine, if you're sitting on a little gold mine, it's easy to just reach underneath your lap, be like, here's a gold nugget, as opposed to going in with like a pickaxe and spending 3.5 years, beginning the mining process. So I'm sitting on some already refined ore, ORE ore. And so that's what I mean. Nathaniel's right, where it's such like a ton of work, but a lot of the time consuming over the years part is going to be like, acquisition of data, and we have data. And so we can move forward from there. It's still work, but it's not going to take years. You can do it in you can knock this thing out in a semester. I think everybody here we should have a nice, it's a really good group this year. It doesn't feel exactly like it because it's all digital. And a digital relationship is almost like no relationship at all, you know. But it's everybody I've talked to in some more personal way, whether that's individual video or phone calls and stuff like that. This is a really good group, and we haven't had a group this good in the graduate program in like 4 years, something like that. We used to, a long time ago, we had a really good group, and then we had this like weird phase for a while where it was just like, it was weird, and then now we're good again. And so I do want to make the most of this group, because it really is, I'm not just saying, this really is the best. Maybe it's our best graduate group since I've been here, but it's at least it's very competitive with the first one, which was amazing. It was like the best group of students ever, and I think we have that again. And we just had this dip, and so now is the right time to do a bunch of research. So I would be motivated to do research, and I would compel you to participate. And also, this is, I will say, this is the best because we have experienced people already. When I first got here, we had this amazing cohesiveness where everyone just got along so well. I mean, it's just everyone's like best friends. And that was rewarding to walk into, and everybody they're on this big team, and they still, like, I get these like monthly emails from the original grad students where everybody who is in the graduate class, they do, like, they come up with this like fake magazine, and they do it like every month. And that was really cool to have such familial experience, but nobody knew shit about research. And so I came in, and I'm like trying to teach people about research, and I have this sort of family experience, this family setting to do it. But here we have what, again, it's difficult to have the full family experience digitally, but we'll be back in the fall. But the personalities, the capacities, I think the ethics of everybody here, the motivation, that is as good as it was when I first got here. But we also have a bunch of people who know how to research already. So we could be so successful if we decide to, like, let's just all get on board and have this great experience. And so I do think we have now the best graduate cohort that I've ever seen. And we should take advantage. It's a good resource. JP says true. And I say true to JP's true. So we'll do a bunch. I think both ACSM and experimental biology this coming year. So just be thinking about what you want to do. If you want to do pure medicine, if you want to do biomechanics, if you want to do whatever, there's lots of opportunity, and we'll take advantage.
Have a good weekend, everyone.
All right. I'll see everybody. Oh, good, Lexi. Yeah, St. Jude's. Yeah, if you can.
Yeah, they've known me, I think this is going on 7 years. So I think they would, and I even know one of the CMOs. So I even think with those connections, they're possibly open to data. Of course, a lot of it has to be what's the term I'm looking for? Like, obviously there's a lot of private information, so they might give us information.
Anonymized. Yeah. Pre-anonymized data sets. That's what I would expect. I don't think they're going to be giving out data sets that have, identifiers of all the patient characteristics that would be able to identify them. But we don't need that's we would just delete that. If they gave us that, we would just delete it anyway, because it just gets in the way. If
Right.
they gave us identifiable patients, those are just more columns in a database. And like, if I'm looking at a database to analyze it, those columns are pointless. I'm not going to analyze that stuff. So for the sake of statistical efficiency, I would delete them anyway. For the sake of statistical ethics, they have to be deleted. So if you can get anything from St. Jude's, any type of data from St. Jude's, that could be very effective, and we could submit probably more experimental biology. I think we've done a lot of, as we've overextended the medical submissions to ACSM and just looking at BMI because it's the easiest thing to analyze for ACSM, but we haven't done EB before, and we have a lot of medical data that could lend itself to a big presence. And I think if we got St. Jude, that would be one more.
Yeah, because when you said experimental biology, I just remembered like, oh, that's right. I think I would have to like go back to working there more full time because I was volunteering there, I think in the beginning of the semester, probably like 15 hours a week. But like I was working in the endoscopy center. So like I could ask them to see if they'd potentially want to work with us. I was working like in the main hospital too, so like I'll try to see what we can get, but
Okay.
and then I don't know if you'd want this because it's a very small, I guess, situation, but like I don't know if you want to like use anything like with dentistry. I can see if there's any stats I can get from my dad.
Yes. Yeah.
Would that be interesting? Okay.
Yeah. If there's some
Lexi,
raw data, go ahead.
sorry, Lexi, going off of your comment about dentistry, if you want, I can
Well,
ask
yeah,
my dad.
yeah, Dad.
Yeah,
Your JP, your dad is like,
yeah, I can
he's
ask
like
him
massive.
because,
Yeah.
yeah, so no, my dad, along with working at Pacific, he actually runs the sort of the residency clinic out of Union City, and they see a lot of patients. So if you need patient numbers, he can probably get those for research if you're planning on that, or maybe cooperating with Dagoni, the school, to see if they can, uh, give us some of that data as well. So
Yeah, so that would be another. So JP, right now you will have a big presence at ACSM owing to your
the monster.
baseball and the monster. Yeah, we'll just refer to it from now on as the monster, owing to the monster.
I think
And
Lexi would enjoy it too, because Lex, you're a baseball fan,
oh,
right?
that's right.
Oh yeah, so it's funny because you guys kept referring to the monster, and I knew it was baseball related, but like
No, it's not the green monster. Don't worry. I know what's not to bring up around you.
I know when you said that, I was like, oh, the Green Monster in Boston. But yeah, I was
You're
like,
like, oh no, not a Red Sox diehard. It's like, no, I know where you're from. I
I
know
was
I know
like,
what you're coming from.
I'll deal with you Dodger fans, but you get a Sox fan, like screw that.
That's me on the opposite side. Like, I don't mind that rivalry, but like Dodgers sometimes are so disrespectful. But yeah, no, it's basically a 1,000 subject database I've been working on. That's basically done. I'm just, waiting, not to say waiting on Jensen, but
No, but yeah, that's fair.
whenever you
That's
get
the
to it,
truth.
whenever you get to it is fine.
Yeah.
But it's basically finding a quantifiable value of a pitcher based on it's sort of like how when in like the drafts, like if it's like not every first overall pick is going to be like a superstar, and not every low level pick is going to be a dud. So that was my whole database, is basically disproving that some of the best pitchers in history have come from lower rounds, and some of the worst pitchers in history have come from higher rounds, even the first round. So it's fun. It's an eye strain to look at for a while, having been the one to punch in all the numbers, but it was all fun and games, I suppose.
It's the diamond in the rough, as they say. Can you identify the uncut gem? Well, statistics give you the tools, the lens through which you can identify the valuable uncut gem. There's a pitcher who hasn't been picked up. Is that the one? And so statistically to figure that out, I mean, it's such a great question you came up with, JP, and and it's such a monster of a database, and we'll get some findings out of it. So that'll be a big ACSM representation, and then if there's dentistry stuff, that'd be more EB.
Sounds good. So yeah,
Yeah.
Lexi, if you're gonna check that out, let me know. I can just I can show you what it looks like. It's I
You
think
know,
it's the best thing I've ever worked on, honestly.
no, I'm proud of you, JP. Like that
Thank you.
sounds honestly like that's brilliant because you're right. Like, and even not in baseball, like even in football, like, everyone's saying like Tom Brady's the best quarterback that's ever lived. And it's like he was round pick number 6,
Yep.
like so it goes to show like the best athletes in the pros aren't like the first drafted. So no, like credit to you. But for the dentistry data, like if your dad, you know, wants to or would like to do that, I'll happily take all his data and organize it and get it ready. And well, of course you'll be working on it with me, but like
Of course, I
get
would
that
love
ready.
it would be an honor to work with the great Lexi Imo.
It'd be an honor to work with the great JP1. And then,
Well, that's all right.
but Courtney, I have 2 databases. I'm just trying to format them so they're SPSS appropriate.
Okay.
They're smaller, but I think they would be interesting. One of them is baseball related. It's Tyler and Cherry's, where we're looking at performance stats with or without fans.
Oh, I like that idea. Yeah.
Yeah, so we have all that. He made
Okay.
the database already.
Good.
I just kind of need to make sure I format it in SPSS, and then
Okay.
I want to see if I could run it to where like I do everything correctly.
Okay.
But then I wanted to show you and be like, hey, is this good?
That's it. Yeah, that's perfect. And then we kind of go over it together. And okay, now here's what I would do. I would tinker with this. I would control for this or whatever. And that's the best way of doing it, is you give it a shot. And sometimes people just, you might connect, but usually I say, okay, let's do this with your swing. I think what we have here is a single, but you're capable of getting a double. Let's do this with your analysis.
Lexi, I have a quick question for you regarding that database. What's the sample size on that? Because I can only, like, for me at least, I can only imagine the the performance based on fan appearance. I can only see that as sort of a smaller sample size, having 2020 been, the most recent season with 0 fan attendance. Is it like calculating the amount of fans in a particular setting for a certain home team, or like how is that calibrated?
So because the 2020 season was very delayed and kind of wacky, we started it when the season was, according to its conditions, more normal or more consistent. So that would be August and September during the baseball season. So we're looking at stats from the August 2019 and 2020, and then the September 19, 2020 stats. And then we split them up because we wanted to see if there was differences comparing the American League versus the National League, because they are different in a sense where like, the American League has designated hitters where in the National League doesn't, just small differences like that. It'd be interesting to compare. But it is very small for a database. But
I recommend for whomever is working on this database, it's a couple of small calculations, but should help with the whole X factor of playing baseball. You and I and Jensen both, we all know that, baseball is definitely a very random game. It doesn't matter. Like, you guys from Babe Ruth to, the freaking cheater, Jose Altuve, no matter, what size you are, what the odds are, you can perform pretty well in baseball depending on your drive. So for that X factor of it, suggest having him include the clutch factor and win probability added. They're pretty easy to calculate on like Baseball Reference, the database the reference guide I use for all the baseball players I've researched. It just basically accounts for a lot of the, quote unquote statistical anomalies that show up in wins. It's like, oh, this, because some players have really hot months and some players have really, like cold months. So it helps account for the randomness of their performance in a given month or setting. Like, say if you have like player A who their team has already clinched the playoffs in September, he probably doesn't have to perform as well as if he would if it were like September 2020 and his team is, like half a game behind the second wild card, and he has to, ramp up his performance even with or without fans. So just a thought, take it as you will. But that was just something that popped into my head regarding comparing months from different seasons in different conditions.
Oh yeah, thank you. I definitely wrote that down as a reminder, but you're right because, if like the Angels were to play right now in Anaheim, it feels like 80 degrees today right now. Whereas like, if we're like on the East Coast, conditions are drastically different. So you're right. I'll definitely um, take that into account as well. We'll write that down.
In addition to that, for batters, because it sounds like you're mostly talking about batters, use I don't know if the database has OPS on it. Also include OPS plus, because OPS plus accounts for ballpark factors.
We actually included OPS already. So.
OPS plus
Plus, okay.
is the variable because it's basically the average. So 100's the average for OPS plus. Anything above 100 is great, and anything below 100 or below 80 is considered bad. 80 to 100 is considered the range of average. But what you're looking for in OPS plus, it is the how many points above or below the average the league OPS is, including ballpark factors and a lot of other extraneous variables that the batter may not have control over. So I like using OPS plus because it's a great normalizer. If you're comparing, say, Hank Aaron in his prime versus Barry Bonds in his prime versus Mark McGwire versus Sammy Sosa, you can normalize their OPS plus, and you can see, okay, so it looks like Barry Bonds had an OPS plus closer to like 200. Hank Aaron is pretty close at like 180 something, and Mark McGwire and Sammy Sosa are pretty close together at about 140 a pop. So you can say, well, technically, according to OPS plus, Barry Bonds was the more efficient hitter. Hank Aaron was second, and then it's a tie for Mark McGwire and Sammy Sosa for third. So, but it just sort of helps with the comparative aspect of analyzing players, even if they're the same player over time, because you can have, for example, I already have a baseball player pulled up on the database. You can have an average of 150 in one season. You can have 125, and the next you can have 156, and then the season after that's 171. So you can see there's a lot of jumps to it, but it's all the same player. It's just over the course of the years. So that should also factor into comparing season to season in a certain player or in a certain group of players.
That's great advice, JP. I'm wrote down all those right now. Thank you.
Really? No, yeah, it's funny. No, I'm working on a little fun because I do research for fun because I don't have anything else to do lately. So, but yeah, no worries. Yeah, glad I could finally put some of the information I've learned while doing this to use. So good.
All right, guys, I'm gonna hop off.
All right, you have a good weekend, Jensen.
You
You
too,
too, Lexi.
you too.
We'll
Bye,
talk soon about
guys.
the research stuff. Bye.
All right, I'll see you.